Welcome to Emilak Online tutorial. Now before us in this tutorial, we'll be looking at the introduction to vector representation. Alright, first of all, let us acknowledge that a vector quantity now can be represented graphically by just drawing a line. Okay, let's say this is A and this is B, which means the starting point is A and it moves to what? B. Now, there are two terms that characterize a vector, and that is the magnitude and the direction. Okay, now let us use this line now as an instance. Now here you have your A, which is the starting point, and B, the ending point. Now the magnitude of this now is just the distance from here to here, so maybe it could be just A. Okay, now the direction now is represented by an arrow. So since it's starting from here going towards B, okay, now this is a typical representation of what? Vector. Okay, so we can actually say here that AB, now this is an arrow that signifies starting from A to B. Okay, and which also tells you that this is a vector quantity. Okay, equals what? A. All right, so the magnitude of this vector AB is A, and the direction is from what? A to B. Okay, now that is that for the representation. Okay, now let's just say, for instance, again we have A, from A to B here, and this B, and this is what? C. Now ideally you're meant to have from A to B and to C. Okay, which means that from A to here you have the arrow, then from B to C here is the arrow. Okay, now from A, which is the starting, so from A to C. Now here is the starting point and here is the ending point. Now we start from here. For us, for anyone, maybe you are here standing, okay, and this is probably your destination. So you have two paths to which you can actually go. You can from here, from A, move to B, and from B down to what? C, right? Or you can move in a single line from A to C. Okay, now this picture here gives you what we call the addition of vector. That is the addition of vector. Okay, now how? Now if you can move from A to B to C, now here is the starting, now here is the stop. Okay, so from A to B, from B to C can be represented by a single line, which is from A to C. Okay, all right, so with that now there is a sort of addition that we'll probably need to implement here. So A to B, okay, let us represent, okay, that will be A to B, okay, then plus B to C now can be represented by its resultant. Okay, its resultant, which is A to C. A to C. Okay, yeah, that is it. So this is in terms of the addition of what? Vector. Now AC here represents the resultant of from A to B to C. Okay, right, and that is that. Now let me add one or two things here also again. Now look at this again. Here we are from A to B, where the magnitude is A and the direction signifies this arrow. So now peradventure we now have, now this is actually the starting point, start, and this is what the stop. Okay, now if someone now tend to move towards this area, so the arrow is in this form, but originally it's meant to be, okay, let me just move this arrow so that we won't get confused. Now equals A. Now but if you are to move from B to A, which will be B to A, okay, this will give us what? A negative A. And that's because moving from B to A is actually opposite to the initial original direction, which is meant to be what? A to B. So this negative sign tells you that BA and AB have the same magnitude but different direction. Okay, they have the same magnitude, which is A and A, but different direction, which makes this what? Negative A. Okay, so this is just an overview of what the vector representation graphically. Okay, now let me move further. Now take a look at this direction of vector. Let's say this is their starting point A, from here down, which is B, now down, let us say C, and let us say D here. Okay, and we now have let me see, which direction should I move now? Okay, let's say this is E. Right, now the direction is in this form, this, and this. So if we can represent this as A, the magnitude, this is B, this is C, and this is what? D, which implies that the magnitude of from A to B is small letter A, from B to C is B, from C to D is small c, take note this is just a capital letter C, and from D to E is a small letter D. Okay, now we can have from here, which is A, you can actually get to C moving this direction, right? Yes, and you can actually get to D from A moving this way, right? And you can also get to E moving this way, right? Now let us look at this. Now the total sum of A, B, C, and D here could actually give us A to E. Then how do we do that? Now here you have from A to B and from A to C. Now here you have AB, okay, AB plus BC now can give us from A to C. Okay, all right. And actually there's another formula you can probably use. You can see this AB and BC, and you can see that B and B is common. Just take this, the first one and the last one, and that's all. Now let us see another one here. Now from A to D, now that means you can move from A to B to C and to D, which is the same thing as what? A to D. So here we can say A, B plus B, C plus C, D, then gives us A, D. Okay, all right. You can even compress that. You can say AB plus AC. This is meant to be AC, okay, then plus CD, then which is equals to what? AD. You can see AD, AD. So just another trick. Now again to E, you can have AB plus BC, okay, plus CD, okay, then plus DE, then which gives us the resultant AE. And actually you can still prove that. Now you can see this is AB plus BC. Now this will give us what? AC, okay, then plus, now this is CD plus DE. Now this can now give us a CE, okay, AE. Now you can see here AE then equals AE, right? Okay, now this is just to add vectors, okay. All right, so you can actually conclude that A, B, C, D will give you, so you have A plus B plus C plus D will give you what? AE. Okay. All right, now if you are to probably make use of this, let me use this, this and this. Now here you are, let me see, P, Q, R, S, T. Okay, now here, and here. Now what do you think will be the resultant of this direction? Let me see, that is PT. Okay, so which means this from A to P, to Q, Q to R, and R to S, and S to T will actually give you what? PT. And that should be PQ plus QR plus RS plus ST. Okay, now here you have, from here, this will give you PR, and this one will give us plus RT. You can see at the end of the day we have PT as the final answer. Alright, this is just the basics to vector representation. If you love what I've just done, guys, subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Thank you and God bless you.